Dear students, I welcome you all to this problem solution series in digital electronics. I am solving the problems from the book Digital Design by Morrisman and Michael Sileti. So in this video, I am solving the problem number 5.4 from the chapter number 5. Okay, the problem is a PN flip-flop has 4 operations: no change, clear to 0. Clear to 0 means reset. Okay, and set to 1 and complement. Okay, these are the 4 outputs: no change, clear to 0, set and complement. When the inputs P and N are this P and N input combinations are 0 0, that is for 0 0 it will give no change. When it is 0 1 it will clear to 0. When it is 1 0 it is set to 1, output is set to 1, and when it is input is 1 1, the output is the complement of the previous output. So these are the given conditions. Now what we have to do, we have to tabulate the characteristic table first, then we have to derive the characteristic equation, then we have to tabulate the excitation table, and we have to show how the PN flip-flop can be converted to a D flip-flop. Now let us solve this problem one by one. So first of all, we have to make the characteristic table. We have to make this characteristic table as per the given conditions. So the given conditions are, the inputs are P and N. Okay, the inputs are P and N. Okay, and we have to find out the Q of T plus 1, that is the nested output. Okay, now we have to follow these conditions. So for 0 0 we have no change. Okay, so for 0 and 0 we will have the previous output, that is Q of T, that is no change. Next we have 0 1. For 0 1 we have, it is clear to 0, that is the output will be 0. Then we have for 1 0 we have set to 1. For 1 0 we'll have output will be 1. It is clear to 0, it is set to 1, and for 1 1 we have the complement. Okay, that means we'll have Q complement of T. It is the complement. So this is the characteristic table. So this is the solution of the first part of the problem, that is the tabulate the characteristic table. Okay, the first part of the problem is complete. Now we have to derive the characteristic equation. For finding out characteristic equation, we have to again make a table giving this input, okay, P and the present state output. Okay, that is P is the input, N is the input, and present state output is, okay, Q of T, and we have to find out Q of T plus, sorry, T plus 1, Q of T plus 1, this is T plus 1. So assuming these are the inputs, we have to find out the next state output, Q of T plus 1. Okay, so we'll have 8 combinations, 0 0 0. Now we have to find out the Q of T plus 1. So we have to find out Q of T plus 1 following this characteristic table. So for in the first case we have 0 0. 0 0 means we will have the no change. Okay, 0 0, that is the no change. The present state output is the next state, will be the next state output. Okay, so 0 0 means, so this will be the next state output, 0, no change, that is previous output was this one, now the output will be this one, 0, same. Okay, then we have 0 0 again, so no change, so it is 1, so we'll have output 1. Then we have 0 1. For 0 1, irrespective of the previous output, we'll have the output is 0 0 1 1. Irrespective of this output, we'll have output is 0. Okay, so we have written here 0 0. Then we have 1 0. For 1 0, we can see that it is set, the output will be 1 irrespective of the previous output. So for 1 0 1 0, we'll have 1 1. Then we have 1 1, and for 1 1 we what will have, which is the complement of the previous output. The next state output will be, so for 1 1 the next state output will be the opposite of this present state output. Okay, so we'll have 1 here, and it is 1 present state output, so the next state output will be 0. So this is the table, and from here we can find out the characteristic equation making a K-map. Okay, so we'll make a K-map. This is K-map for Q of T plus 1. So we have inputs are P, N, and Q. So this came up is the similar process to the previous examples, previous chapter problems. Okay, 0 0 0 1 1 1 1 0. Okay, now we will put this q of t plus 1 values here. 0 1 0 0 0 1 0 0. Then we have 1 1 1 0. So we have to put like 1 1 1 0. Okay, so this will be one combination and this will be the second combination. Okay, so we'll have q of t plus 1. This is the characteristic equation. Is from this term what we'll have n bar of n bar q, n complement q plus, and from this combination we'll have it is p and q bar, q complement. Okay, so this is the characteristic equation. So or we can rewrite it as p q bar plus n bar q. So this is nothing but the characteristic equation of a jk flip-flop, where j is p here and k is n here. Now let us go to our third part of the problem. In the third part we have to find out the excitation table. So for in excitation table we'll have q of t and q of t plus 1 as input. We will have to find out the respective inputs, that is p and n. Okay, we have to find these values from this characteristic table. From this table we can find out. So we will have for combination 0 0 0 1 1 0 1 1. First of all we have 0 0. Now here we can see that we have 0 0 here, okay, and 0 0 here, 0 0. So for the first and the third case we have to see the respective inputs. So for both this, suppose this one and this one, what we have, the p value is 0 and 0 for both the case. Okay, so we can write it as 0, okay, and n value is 0 and 1. Okay, so what we have to write, we have to write here a don't care. Okay, because irrespective of the input, an input will have this output 0 0. So 0 and 1 we have to see here. So 0 1 0 1 is this one, okay, and 0 and 1 is this two, fifth line and this seventh line. So we have to see now the respective inputs. So these are the p and q, p and n are the inputs. Okay, so what we have to do, p value is 1 for both the case, so we'll write p is equal to 1, okay, and n value we can see that it is 0 and 1. Okay, so you can write it as don't care condition. Now we have 1 0. Okay, now 1 0, for 1 0 we have to see this one. Okay, this is 1 1 0 and another 1 0 is the last case. So for these two row we can see that the p value is 0 and 1. Okay, so we have to write it as don't care. Okay, and n value, if we see these two row, okay, and n value will be 1 and 1. Okay, so we can write it as 1. Next we have 1 1. So 1 1 we are remaining with this one. So 1 and 1 and 1 and 1. So the respective inputs are p is 0 and 1. Okay, so we have to write here a don't care condition, and n value is 0 and 0. Okay, so we have to write here 0. So this is the excitation table. So up to third part we have completed this problem. Now we have to show how the p-n flip-flop can be converted to a d flip-flop. In the fourth part we have to convert this p-n flip-flop into a d flip-flop. Okay, so I have drawn here a p-n flip-flop. Okay, this is the p input and this is the n input. Okay, this is the p input, this is the n input, okay, of this flip-flop. We have this output q and the complemented output is q bar. If we give this n input value, that will be the inverted value of the p input. Okay, so what we'll have, we'll have a d flip-flop. It will work as a d flip-flop, that is the data in flip-flop. Okay, so this is the solution of the part D. Now let us verify this. Okay, so whenever we give 0 at d input, okay, and the output should be 0 because it is the operation of the d flip-flop. Okay, so whenever we give 1, its output should be 1. Now if we give 0, we'll have 0 here at this p input, and in the n input we'll have, because it is an inverter, we'll have 1 So if we give here 0 input, so P will have 0 value and N will have 1 value. Okay, so 0 and 1, that means we can see that 0 and 1. So the output will be 0. 0 and 1, output will be 0. For 1 and 0, output will be 1. So this output will be 0. Now if we keep one input, so this will be 1 and this will be 0. So for 1 and 0 at the input ports P and N of this P and flip-flop, the output will be set, that is 1. Okay, and this will be the inverted one, so we'll have here 1 and 0 respectively. So this is the D flip-flop conversion of the P and flip-flop. Okay, so thank you for watching. If you have any question, please put it in the comment section below. Also like, share and subscribe to my channel. Thank you.